So, hello everybody, and we're going to eventually race all the way up to 99, but let's learn how these steps are going to go and try to find out how to get where we're going the fastest that we can. So the idea here is that you have a collection of numbers, and at the start, your only ingredient in your collection is the number 1. And at each step, you can take an action, which is adding any 2 numbers in your collection. So at the beginning, you don't have a lot of choices. Anybody want to suggest something about what you could do to start off here? If the only number you have is 1, and the only action you're allowed to do is adding 2 numbers from your collection, what could you possibly do? Maybe type something into the chat, I guess, is the
I'm going to call on Michael, who has their hand up. So Michael, you should be able to unmute yourself once you become a panelist.
Go ahead.
Well, 1 + 1 = 2.
Hey, that is a great action to take. Okay, and now that means we've got 2 in our collection, and we've done 1 action. So we finished the race to 2. It took 1 step. All right, maybe we'll keep track of our high scores over here. Race to 2 steps 1. Okay, and who would like to suggest our next step, our next action? I see a whole bunch of hands going. This is so exciting. All right. Do I have the
Oh, if you call on someone, Josh,
power? Oh, I
I'll
do.
panelist.
So I can just say like, Nicole, go for it. And then
Yep, exactly.
if I click the promote to panelist button, something
I already
will
clicked
happen. Okay, cool. Okay, great.
Do that. Go ahead.
2 + 1 = 3.
Yeah, 2 + 1 is 3. That is definitely an action we could do. So I'm kind of putting the actions on the lines between, and then I'm putting the collection into the next box. So we can see like we have this collection, we do this action, we get a new thing in our collection. Now we do this action, we get a new thing in our collection. But I think with the arrows, it gets too messy. So I'm not going to draw those. I'm just going to put the actions on the lines between. Okay, so we've accomplished our race to 3 with 2 steps. I want to suggest a kind of difficult goal here. Let's try to get to 11. Maybe I'll leave some space for some other things we could race to.
Yeah, that's a 2.
Yeah.
Is my writing too messy? So, Srija, would you like to suggest a next step if we're trying to race to 11? What numbers from our collection would you like to add?
My name is Ashwin.
Ashwin, hello.
Yeah, my mom is Rija.
Got it. All right, Ashwin, what would you like to add for our next action?
3 + 2 is 5.
Okay, that is a fine choice. 3 + 2 is 5. So now we have 5 in our collection. Great. Nina, what would you like to do next?
Nina should be unmuted now.
Okay, so I go by Daniel. Nina is my mom's name. And
Okay,
I
great.
next step
Daniel,
is to
hello.
do 5 plus 5.
We could do 5 plus 5. What does that equal?
10. 10.
10. Okay, cool. 10. All right, so we have 10 in our collection. Yeah, there could definitely be some Fibonacci stuff going on, people. Talking about some different strategies here.
I think actually, Josh, since you're going to be calling on a lot of people, anyone who has their hands up now, I'm actually going to promote to panelists so you can more easily call on them more quickly. So Abigail and Anurajani,
Okay,
for
so
instance, I'm
even when
going to
they're
promote them.
even when they're panelists, they'll still show up in the attendees list too.
They'll show up on the panelist side.
All right, Abigail, I guess you're up next. Okay, I'll try to keep everything. All right, Abigail, what's your strategy here?
10 plus 1 equals 11.
Wait, what equals 11? I like equals 11. That sounds great because that's what we're racing to.
10 plus 1.
10 plus 1. Oh, okay, great idea. And we got 11. And it took us, we can count the actions 1, 2, 3, 4, 5. And I see some people in the chat suggesting some other ways. I think one of the other ways they got to 5 went like this. We started with 1, and the first action was still 1 plus 1 equals 2. So now we have 2. And they did 2 plus 1 equals 3. Now I have 3. And they did 3 plus 2 equals 5. Now I have 5. And they did 5 plus 3 equals 8. And then they did 8 plus 3 equals 11. And that also took 5 steps, 5 actions to get to where we're going. So that's kind of a tie. I'm not sure what we should do for a tiebreaker. Maybe the second one has, at this step, has a smaller number. It's a tie. All of these are exactly the same both times. And so this is kind of the tiebreaker. So maybe the tiebreaker with the smaller number we'll say is a winner. So maybe we could look for even a better race to 11. Maybe somebody could do it with 4 steps. That would be fantastic. Or if you have a 5 steps, could you do one where the tiebreaker is smaller? Like, could you start out 1, 2, 3, 4 instead of 1, 2, 3, 5? Because then the tie would be 1, 2, 3 would be tied, but then 4 would be smaller than 5. So the smallest choice for the tiebreaker. So this is all tie up to here, and then smaller here. So we'll say that one wins in terms of being a smaller solution. Maybe we'll hunt for the smallest solution. Maybe somebody could do it in 4 steps, and then that wins no matter what. We don't have to worry about tiebreakers then. So if you have a 4-step idea for 11, that's great. Or maybe somebody could find one that starts out 1, 2, 3, 4 instead of 1, 2, 3, 5. Is that possible?
We got a few hands already.
Oh, we got a bunch of hands.
Yeah.
Wow. Okay. Cool. Yeah. All right, Michael, what do you want to tell us?
2 plus 2 would make 4.
All right, 2 plus 2 could make 4. So this is not going to be a good tiebreaker because 4 is bigger than 3, but maybe you're going to get it in 4 steps, and then that would definitely be a better solution. Okay, what's your next action?
Probably 4 plus 2 makes 6.
Okay, that sounds like a plan.
And then 6 plus 4 equals 10.
Okay. So we got 10 for our collection.
And then 10 plus 1, basically.
Sure. Then we got our goal of 11, and it took 1, 2, 3, 4, 5 actions still, 5 steps. And we can see here the tiebreaker is 3 versus 4. 4 is bigger. So far, this one is still our champion, if you like.
I have
Anybody have any better ideas for 11? Something that could maybe break the tie. For example, what if could we start out 1, 2, 3, 4 and still get to 11 in 5 steps? That's pretty small. 1, 2.
I have one that'll take 4 steps.
We start out 4 steps. I want to hear only about the 4-step plan.
So you basically do 1 plus 1
What are we gonna
equals
do?
2, and then 2 plus 2 equals 4. And then you do 4 plus 5, which is 9.
5? Where did 5 come from?
Oh, sorry. You do 4 plus 4 plus 4.
4 plus 4. Okay, cool.
And then you do oh wait, that's not, never mind. That's 5 steps.
No, it was a great idea. We learned something really interesting here, right? Because
Actually,
what you did here
oh
was
wait,
at every
wait.
step you made the biggest possible number,
Yeah, so
which is not great
next-
for tiebreakers, but it's good for getting big numbers really fast. Yeah, go ahead.
Next I would do is 8 plus 2.
So you're kind of breaking up, and I'm not sure if it's my internet connection or yours, but I missed whatever you were saying.
Yeah, you're breaking up for me too.
Okay. I'll see if I can do anything that might improve my situation here. Right.
Yeah, I think you said Arjun said 8 plus 2. What was that? Arjun?
Yeah, that's correct. And after that, 10 plus 1.
Okay, got it. So what this is going to do is sort of the opposite of what I was saying our tiebreaker was going to do. You at every made the biggest number you possibly could, and you only slow down at the end so that you didn't go over 11.
Yeah.
And so this is pretty useful in terms of seeing, we know that in 1 step, the biggest number we can get is 2. In 2 steps, the biggest number we can get is 4. In 3 steps, the biggest number we can get is 8. So we have kind of some idea of the best possible biggest number we could get to with 3 steps. So we know everything past 8 is going to definitely take more than 3 steps, because that's the biggest we can make. Is if we add our biggest number plus itself, that's the biggest we can make at every step. So that definitely says a lot about how we could potentially get to big numbers fast. So it doesn't win the tiebreaker because the 4 is bigger than 3. The tiebreaker is to try to make the smallest numbers at the beginning and only get big when you have to at the end, but still finish in 5 steps or less if you can. Yeah. Okay, Arjun, what do you have to say?
Oh yeah, that's what I
Oh, okay.
was doing.
Great. All right, Daniel.
What's our goal? To get to 11.
So we're trying to get to 11. And what we've seen here is we did it with the biggest possible number at each step. Like
Yes.
at the step where there's that 8, we couldn't possibly have any number bigger than 8. But could we do it with the smallest possible number at each step? Can we go 1, 2, 3, We did 1, 2, 3 already, but we did 1, 2, 3, 5. Could we start 1, 2, 3, 4 to break the tie? Or what's the
if we
smallest things we can start
started-
with?
The issue is 11 is a prime number, so so the only ways you can get to it, the fastest way to get to it is a 5 plus 6, I believe.
Ah, 5 plus 6. Okay, cool.
So
Yeah, that's a good point. Like if we're going to make 11 somewhere earlier in our collection, we have to have either 1 and 10. So maybe we could make 10 and then add 1. We've done that a couple times. Or we could try 2 and 9. I don't think I've seen any 9s yet. Have I seen any 9s yet? No, we never made 9 yet. So you could have a 2 and then make a 9 at some point, or you could do 3 and 8. But your last step is going to have to be combining 2 numbers to make 11. So we're looking for what's the fastest way to get 2 of these numbers in our list.
So I think to start off with 1 plus 1.
I think we pretty much have to do that.
Yeah.
Yeah. You know,
Then
oops,
2
that makes
plus
2,
1.
not 1. Okay, hold on. 2. 2 plus 1. That's definitely an option.
Make
If
a
you're trying to
3.
stay small, that's the best option.
Then 3 plus 3 to make 6.
Ooh, that's a new idea. Okay.
Uh,
I think that's a new idea. We had 6, 3
Uh,
plus 3. No, we've had 2 plus 4 is 6, but we've never had 3 plus 3 is 6. so
then
that's new.
6 plus 3 to make 9. And we
Okay.
can, I don't know how to make 11 in 4 turns, but there are many possibilities for in 5 turns.
It sure looks like
like
it
here,
because we can
another-
finish here. Yeah.
9 and 2.
Yeah, we've got a 9 and a 2, so we've gotten our goal in 5 steps. I'm still really curious. What if we start off the slowest possible way, just counting by ones? 2 plus 1 is 3. 3 plus 1 is 4. Could we make it up to 11 in just 2 more steps now? And is it still possible, or are we doomed? Too small, can't get 11. Julia, what do you think? Julia, there, you want to suggest something to do for our next step here, or should I call on someone else?
Hello?
Hello.
Hey, Anders and Jason, come on.
Okay.
Okay, so I did 1 plus 1 is 2.
Yeah.
This one takes 5 steps.
Okay.
So, and then 2 plus 2 is 4.
Okay.
And 4 plus 1 is 5. 5 plus 4 is 9.
Oh, yeah.
And then 9 plus 2 is 11.
Cool. Yeah. I guess just for short, I'm starting to leave off some of the additions, and you're going to have to hunt and make sure that the things I'm doing are actually legit. Okay, I have seen another one. 1, 2, 3, 5, 6, 11. I'm still curious about this 1, 2, 3, 4. Nicole, did you have something to say about that one? Nicole, do you want to unmute and tell us something about your idea here? Because you had your hand up.
Go ahead.
We want to do another equation.
So
Okay, tell me about your plan.
You start with the 1 through 4.
1 plus 4.
No.
Oh no, 3 plus 4
Oh, 3 plus 4. Okay.
equals 7, and then 7 plus 4 equals 11.
Whoa, that's great. So it is possible. You can start with 1, 2, 3, 4, and then 7 is just enough to make 11. The 7 is also the smallest you could make at that point, because if it was less than 7, and you added any of the smaller numbers you have, 1, 2, 3, or 4, it would be too small. So this, I think, is the best possible one, like with the smallest numbers at each step. If we had, well, 1, 2, 3, 4 is the smallest you can go, is counting by ones. You can't add anything less than 1. 1's the smallest number we have. And then after that, 7 is the smallest you can go to, because if it was less than 7, and then you added the smaller numbers before it, it wouldn't get to 11. So 1, 2, 3, 4, 7, 11 is going to be kind of our winner here, I think, for 11. So I'd like somebody to suggest, maybe just type into the chat, some kind of medium-sized number, let's say more than 11 and less than 99. And I want to see 2 ideas. Which one do you think is going to be easy? That means it'll take not many steps. And what's a number you think will be hard? It'll probably take a lot of steps compared to the other numbers that are between 11 and 99. I'm seeing numbers, but I'm not seeing you telling me if you think they're easy or hard. So now I'm confused. Okay. Yeah, okay, let's take a look at some of these. Yeah, 20 is definitely a good one. So let's say our goal is 20. And let's try to see how many steps we can do that in. 12 is probably pretty easy. Yeah, let's look at 12 next. Then we'll go on to some harder ones. All right, so if our goal is 20, how are we going to get there? We'll start with 1. And then what should our first step be? Michael, do you want to say something?
Mm-hmm. 10 plus 10.
Ooh, so that's a great idea. For our last step, we could have 10 and then 20. So what you're kind of suggesting here is maybe one way to get to the goal is not to work forward from 1, but to work backward from what our goal is. If we had a good way to make 10, then our last step could be 10 plus 10 equals 20. I think that's a great idea, to think of not just working forwards, but also what happens if you start working backwards? What numbers might you wish you had to make 20? And what we've seen with 11 is there can be lots of combinations, right? We made 11 from 9 and 2. We made 11 from 7 and 4. We made 11 from 10 and 1. We made 11 from 8 and 3. We made 11 from 10 and 1 again, right? So we did a lot of different combinations. So the possible ways to work backwards, there's a lot of them. But here it seems like 10 plus 10 is 20 is pretty nice. How are we going to get to 10? What do you think might be, maybe let's continue that idea. What might be the step before 10 or the step after 1? Maybe we can figure out how they can meet in the middle if we work forward from 1 and backward from 10 a little bit. Yeah, Ella, what would you like to say?
Are you telling us something? I have a 1 for 20.
Okay, tell me your ideas.
Well, actually to get to 10, more like.
Great, well, if you can get to 10, then we've already learned how to get from 10 to 20, so that's great. You can combine our working forwards and backwards.
You do 1 plus 1.
That's a good plan. At the beginning, that's really pretty much all you can do because you only have 1 to work with.
And then 2 plus 1.
2 plus 1. Okay, now I've got a 3.
And then 2 plus 3.
Ah. Now we've got a 5.
And then you do 5 plus 5.
5 plus 5. So wait a minute, 20 is way bigger than 11, and we just did it still in only 5 steps. Whoa. 20 still took only 5 steps? That's kind of amazing. It's so much bigger than 11, and it only took 5 steps. It's hard to imagine that we could do it in less than 5 steps. And if we're going to end up with 20, this number has to be at least 10, because otherwise we're going to be in big trouble there probably. And then to make 10, this number has to be at least 5. So maybe this is about the big winner. Like this, maybe I'm ready to just already put a red box on this one, as I don't think we can do anything smaller than that. I'm seeing a couple ideas for 12 in the chat. Julia, did you have something in mind for 12? Okay, so let's say we're starting with 1, and we're going to end up with 12. I hope I'm leaving enough space. Yeah. Lorraine, what do you want to suggest?
1 plus 1. 1 plus 1 equals 2.
Okay.
And then 2 plus 2 equals 4. 4 plus 4. And then 8 plus 4.
Okay, I left too much space. You did it in only 4 steps. So even though 12 is bigger than 11, it looks like we can do 12 in 4 steps, but 11 took more. It took 5 steps. So that's kind of interesting. Oh, I see some other ideas here. Some other people were saying for 12, we could try going 1, 2, 2 plus 1 is 3, 3 plus 3 is 6, and then 12. Maybe that's like a working backwards idea. Oh, if we could get 6, we could do 6 plus 6 to get 12. If we could do 3, we could do 3 plus 3 to get 6. So maybe that's one with the smallest numbers we can use. 1, 2, 3, 6, 12. Yeah, pretty cool. All right, let's try some of the ones that people were suggesting are going to be really hard. Okay, I saw some crazy suggestions for what might be the hardest number that's less than 99. Let's try 87. Whoa, that's a big one. We could start with 1. I think I'm going to leave a lot of space to get to 87 because it might take us a lot of steps. Anybody have a suggestion of how you'd like to work forward or backward to get from 1 toward 87 to get closer, or to get from 87? What numbers might you have before that in your collection to get there? Whoa. Yeah, Daniel, what do you think?
So I think the general goal for such a high number in this case is to try to get numbers divisible by 3, because 87 is a divisible by 3.
Okay, so what you're noticing about 87 is that 87 is 3 times something. In particular, it's 3 times 29.
Yes.
Okay, interesting.
So if you want to get it, your goal is to get 29. So you can do 29 plus 29 and then do it another time.
Okay, hold on. So we want to take 29. We want to add up 3 29s. We add up 2 of them and we get 58. And then we have another 29 added into that and we get 3 29s, which is 87.
Yes.
So that's a strategy for working backwards from the end. If we can get to 29 as quickly as we can, then we could finish by adding up 3 29s, which takes 2 actions to do. So if we had a good solution for 29, that would be at least a pretty good solution for 87. I like it. All right, great. Now how are we going to get 29?
So first, I think we need to start off with 1 plus 1, obviously.
Okay, I think we're getting used to this same starting idea happening a lot, because what else can you do?
Then 2 plus 1 to get to 3.
Okay. We have choices. We could have gone for 4, but maybe 3 is going to turn out to be more convenient.
So then 3 plus 3 for 6.
Okay. I'm not really seeing 29 yet, but hopefully you've got a plan.
6 plus 6 for 12.
Okay.
12 plus 12 for 24.
That gets pretty close. We're getting warm now, but now we're gonna have to slow down a lot to
Yeah.
not go past 29, right?
Mhm. So
I wish we had a
24 plus-
5, but we don't.
Yeah. So 24 plus 3,
Okay.
and then 27 plus 2. And then we just repeat what
Oh.
we discussed earlier.
I left one space too many for your plan here. All right, so this was 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. So I guess we have two questions now. Question one, can we find a better solution for 29? Right, this 29 solution took 7 steps, 7 actions, these 7 right here. So either we could try to do 29 in less than 7 steps, or maybe we could try a different ending that isn't 3 29s getting added up, but some other plan at the end. Some other numbers besides 29 plus 58 to make 87 as our last step. Okay. Yeah, I see a nice strategy that's based on groups of 10, still 9 steps. Okay. But I like this other way of looking at it. So we looked at 87 as being made of 3 groups of 29. But because of the way we like to write our numbers, when we think of 87, we usually think of 8 groups of 10 plus 7. Okay, cool. So this suggestion was, let's focus on using our 2s and 3s to get a 5 as quickly as we can. Then that can make a 10. And then we can work with our groups of 10 to get up close to where we want to go. 20 plus 20 is 40. 40 plus 40 is 80. Now we're really warm. We need 7 more. And hunting back through my collection, I see I can get 7 in 2 more steps. So that's a really different kind of strategy. It might be really great for some numbers. Here it looks, well, still 1, 2, 3, 4, 5, 6, 7, 8, still 9 steps. In some sense, it wins the tiebreaker, right? Because here we had 1, 2, 3, 6, and here we have 1, 2, 3, 5, and 5 is smaller. So this is slightly better from our tiebreaker point of view. But what I really like about it is it's a different kind of strategy, right? Before we said, let's work backward from 87. Maybe we want to make it by combining 3 29s. Here we're saying, well, let's view 87 as 80 plus 7. Let's make 80. Let's make 7. Let's add them up, right? We have 2, 80, and 2, and 5. So we made an 80 and we made 7 with 2 plus 5, and then we smooshed those together. Right. This one, we thought, aha, since 87 is 3 times 29, if we can get a 29 here, then we know we're just 2 steps away, because 29 plus 29 is 58, and then 58 plus another 29 makes 3 29s, which is 87. So that's pretty cool. And so then the question became how to make 29, and this was one idea of how to get to 29, was to go through this path. But maybe could we find 6 steps way to do 29, and then that would improve that? Or maybe like here at the end, when we got to 80, we needed 2 more steps for 87. Maybe there's some sneaky way to make a 7 earlier that's going to help. And then, I don't know, something cool might happen. Or maybe groups of 10 isn't the best, but there's some other strategy. I don't know. There's lots of possible things we could try here. But I like these different ways of thinking that we're seeing here. Right? We're trying to get to 29. Yeah. So that's one way. But we're trying to make 80 and we're trying to make 7. That's another way to get 87. Pretty cool. I don't know. What else do people want to try? Yeah. I'm still wondering if it's possible to get 87 in 8 steps somehow. So maybe we can fiddle more with 29 and see if we can do better. Or maybe we can still keep trying other strategies besides using 29. I don't know. $29 does seem like a kind of hard number to make. Maybe it just takes 7 steps to get 29. Maybe it can't be done in 6 steps. I don't know. How are we going to investigate? What should we try for 29? Yeah, Michael, what's your idea?
9 times 3, and we get 3 times 3 equals 9. So 9 times
Ooh.
2 equals 29. That'll only take through many.
Okay. Well, remember, our only actions that we're allowed are adding. So it takes us a while to get to 3. And then if we want to combine 3 3s, that takes a couple of adding steps also. And then if we want to get 3 9s, that takes a couple more adding steps. And then we have a 2 conveniently waiting already to be used again. And that took 1, 2, 3, 4, 5, 6, 7 steps. So that's kind of a tie with our other way, I guess. Still took 7 steps. It was a little smaller though. I guess this one wins the tiebreaker because here we have a 9 versus a 12. But I think this one wins even more because we have a 5 instead of a 6. These are all good ways. I like this way, 3 groups of 9, and then 9 made of 3 groups of 3. Pretty cool. Still 7 steps though to 29, and then 2 more steps to 87. Yeah. Lorraine, do you have another idea you want to share? Because what I saw from you in the chat was pretty similar to the method over here, but maybe you have more ideas. All right, well, maybe we just leave this for a little while and say, well, you know, 87 takes 9 steps, maybe, but maybe there's a way to do it with less than 9 steps. I don't feel very sure about that from what we've had so far. Seems like a pretty hard number. I saw some people saying, let's go for 99, since that was, after all, the big title plan here was to race to 99. Do we want to work forwards from 1? Do we want to work backwards from, I better leave lots of space. 99 is big. Yeah, Daniel, what would you like to say to start us off?
So like the previous one, this one's divisible by 3, so it can get to 33.
All right, so we're going to hope for 33.
And the easy way to get to 33 is to get 16, because then 16 plus 16 and then add 1 for the next step, and then you get 33.
So we definitely have a 1. So if we had a 16, we could make 32.
And it's rather easy to get to 16, because from 1 you can get to 2. Then
16 is a nice number. Yeah.
Add 2 plus 2 to get 4. 4 plus 4 for 8. 8 plus 8, 16.
Oh, and we're already here. I left way too much room. Okay, wait a minute. This is kind of amazing. 99 is a big number, but so far we did it 1, 2, 3, 4, 5, 6, 7, only 8 steps. So 87 we thought took maybe 9 steps, but 99 looks like it takes only 8 steps. I have a hard time imagining a faster way than this, although we did have this one really slow step in here where it only went up by 1. compared to all these fast steps where we're going up by really big amounts, kind of the biggest amounts we can a lot of the time. So we have one kind of slow step, but that's not very many slow steps. That was pretty fast. Yeah. 99 is a pretty nice number because we have this really fast race, fast doubling. We can double our number each time. That's the fastest way to get really big, is if we add our biggest number plus itself. Whoosh. So now that we see this doubling, that kind of means numbers that are kind of built around these 1, 2, 4, 8, 16, 32 are kind of fast ones. And that kind of explains maybe why 29 is kind of hard, because it's just a bit under 32. And 87 seems like it's in a pretty awkward spot when we look at this kind of race. I still wonder if we could find a faster way for 87, or maybe not. Maybe 9 steps is just the best. Yeah.
All right, Joshua, we have like about 5 minutes.
Great.
5 minutes.
All right, so I think we have a pretty good solution for 99. Who wants to suggest another number between 1 and 99 that they think will be really hard? It might take 9 steps, or maybe even more than 9 steps, because it's going to be so tricky to make it. I want to try one more really challenging one to wrap us up here. Yeah, okay, 98, 97 that are up close to 99. Sure. I wonder if we can modify something like this to get 98 in almost the same number of steps. So let's see. I'm going to move this out of the way a bit here. Just remember those. Let's try like 97. 90, you know, somehow odd numbers seem harder to me than even numbers. I don't know. So let's try getting to 97. 97 is pretty tough. If you try to think about, like here, we thought about 33 times 3 to figure out how to finish here. And if we think about 97, it's 1 times 97. That's it. So the something times something strategy is not going to be great here. We could try to make 90 and make 7 and add them up. That doesn't sound great to me either. Who's got an idea for 97? Yeah, 79 might be harder, actually. I'll give you a hint. Let's continue from here and see what we can do. So we'll just copy this same work up to here, which was not very many steps. What should we do next if we want 97? At least this is a fast way to get there. "33 times 3 is 99.
Nicole has their hand up.
Oh, there's a couple of good ideas here. Okay, Nicole, go ahead. What would you like to do here?
32 plus 32.
32
Okay.
plus 32.
Whoa, yeah. 64, that's a big one.
64 plus 32.
Okay.
And now you're at 96. What do we need to get to 97? 96.
96 plus 1.
1. All right. And then we win. 1, 2, 3, 4, 5, 6, 7, 8 steps. And there's a little bit of fiddling we could do to do some tie breaking and get some smaller numbers in our list somewhere, but it's still going to take 8 steps for sure. This is a good solution. Very solid. Nice job, Nicole. So it turns out that computers do this kind of work all the time. It turns out to have to do with fast ways of calculating big exponents of numbers and stuff. And so it's actually an interesting computer science problem to figure out what's the fewest steps you can use for these kinds of things. But there's a lot of interesting surprises in here and patterns that you find, and then exceptions to those patterns and strategies that you find, like our multiplication strategy, our doubling strategy, our using groups of 10 strategy. So there's a lot of good stuff to play with in here. Thanks everybody for all of your ideas. And thanks for inviting me. Good to be here.
Yeah, thank you so much again, Joshua. Thank you so much everyone for participating. That was awesome. There was like so many ideas coming in. I'm sure Joshua was like trying to write down like all these ideas as quickly as possible. Yes, so thank you so much. We are done for today. We will see you all next Monday. Can you do negative numbers? That's a really good question. Joshua, can we do negative numbers?
You can keep adding one at a time, yes, but adding that many ones I don't think is usually going to be the fastest way, but maybe occasionally it's useful to have all those small numbers that you would make. Negative numbers turn out to be pretty tricky in this kind of setup. You get to a lot of interesting complications if you start allowing subtraction also, but sometimes subtraction would be really useful. Like in trying to make 29, maybe it's a great idea to go over 29, maybe to 32 or something, and then take away a couple. So yeah, there's definitely some interesting questions about what changes if you allow subtraction, or what if you allow multiplication and not just addition. So yeah, it turns out to not connect to the same computer science problems, but it does connect a lot to just playing with arithmetic and having a good time.
Yeah, pretty much. They can try these out. They can try using addition, subtraction, multiplication, division, see what happens. Yeah,
although for me, I had plenty of mystery just sticking with addition that kept me busy for a very long time, thinking about which big numbers are easier or harder to make, which numbers are the hardest, and what does that look like? And then what if you go and try to really find what's the tie-break winner, smallest numbers used in your list, and then what patterns do you find in that? Gets pretty amazing. There's a lot of stuff to discover there in terms of these patterns.
Awesome. All right, so we're gonna end the Zoom call right now. So we'll see you again. Have a great Monday, everyone. We'll see you next Monday. Bye.
Bye, thank you.
Bye.